Hey, today I'm going to talk about photochemical smog. So you need to be able to write equations for the formation of nitrogen oxides, so nitric oxide and nitrogen dioxide. Describe and write equations showing the role of nitrogen oxides in the formation of ozone in the troposphere, and explain what primary and secondary pollutants are. So what is photochemical smog? So it's a form of lower atmosphere pollution that you get commonly in cities. So here you can see this kind of browny, dirty layer that's sitting above the city here. That's photochemical smog. Major cause is cars. So cars give off two main pollutants initially, so nitric oxide and hydrocarbons, and other pollutants called secondary pollutants react with those or react from that, and they produce the photochemical smog. Photo means light, chemical means chemical, so you need to have light to get this to run. The activation energy is provided by sunlight. And you need to have stationary air to give time enough for the reactions to occur before you get photochemical smog forming. So I'll just explain the difference between primary and secondary pollutants. Primary pollutants are pretty much exactly what's coming out the tailpipe of a car, for example. So it's the thing that's produced primarily by a process and then that's emitted. You don't emit secondary pollutants. They form when you get reactions of primary pollutants with other primary pollutants or with things that are existing in the environment. So ozone is one of the things that's produced. So if we look at our diagram over here, we can see ozone is a secondary pollutant. That's produced from nitrogen and nitric oxide over here. So they react together to make the ozone, which is the secondary pollutant. Nitrogen oxides can be reformed when ozone dissociates, however, so that means that they're both primary and secondary pollutants. So one of the reasons why nitrogen oxides aren't good is because they're respiratory irritants. So how do we make nitric oxide? So nitrogen and oxygen react in the internal combustion engines of cars or diesel vehicles or in industrial furnaces. The triple bond between the nitrogen atoms breaks up and it reacts with the oxygen to produce the nitric oxide. Hydrocarbons are also a primary pollutant. So they're the major constituent of petrol. When you burn the petrol, not all of it gets burnt, so some of the hydrocarbon comes out the tailpipe. So they go out via the exhaust system with the nitric oxide and the other waste gases. So in the atmosphere, the nitric oxide is converted into nitrogen dioxide by a few different pathways. You don't need to go into the details there. So nitric oxide reacts with oxygen to produce nitrogen dioxide, and that's that brown gas that we see in that haze above cities. Nitrogen dioxide is very reactive. So nitrogen dioxide can absorb HV here is a photon of light in the violet part of the spectrum, and it dissociates into nitric oxide and an oxygen radical. The atomic oxygen here, that can react with oxygen to make ozone, and ozone is one of the secondary pollutants that is quite not good. The hydrocarbons that we talked about, they can enter into reactions with other molecules that are existing in the atmosphere and are also free radicals like the oxygen radical we had before, to make other secondary pollutants like aldehydes and peroxyacyl nitrates. So again, if we have a look, this is LA here, you can see this brown haze, that's nitrogen dioxide plus ozone in a big mix. You can see the nitrogen dioxide, you can't see the ozone. To get this to happen though, you need what's called an inversion, which is where you have an inversion layer that keeps the air underneath in a very stable position, and you need sunlight. So stable air with sunlight, with the emission of your primary pollutants, leads to your production of ozone and nitrogen dioxide. So what are some harmful effects of ozone and nitrogen oxides? Ozone and nitrogen oxides, they're respiratory irritants. They're not very good for you if you breathe them in. So coughing, wheezing, if you have asthma, they can cause issues. So they're a bit of a problem. Also on non-living things, because they're quite reactive, they could cause rubber to crack or perish. You can break down plastics as well. So they're not good for the built environment as well as for living things. Plants can also suffer when they're exposed to ozone in the atmosphere. So you get yellowing of leaves, and whenever you damage leaves, you get photosynthesis rates decreasing. Nitrogen dioxide has similar effects to ozone on plants and animals. We've also seen that oxides of nitrogen can cause acid rain, so they react with water in the atmosphere to produce nitrous and nitric acid. So here's an example question. It says nitric oxide in the atmosphere increases as a result of the decomposition of kudzu leaves. Describe how the concentration of ozone in the troposphere over a given area could increase as the number of kudzu plants increases, and give reasons, plural, why such an increase is undesirable. So we'll start by talking about ozone. So you could have any of the equations we've had that go to the production of ozone. So nitric oxide plus oxygen going to nitrogen dioxide going to nitric oxide plus the oxygen radical, then the oxygen radical reacting with oxygen gas to produce ozone. So any of those would be handy to have in there. You want to talk about what's happening in those reactions, so not just writing the equations. So nitric oxide reacting with the oxygen in the atmosphere to form nitrogen dioxide dissociating because of the sunlight to produce the oxygen radical, and then the oxygen radical reacting with oxygen gas to form the ozone. So you'd want to talk about those. Because it says the word increase, you'd want to say the increase in the number of kudzu plants would lead to an increased concentration of nitric oxide, which eventually leads to the increased concentration in ozone. Give reasons why it's undesirable. So again, you're going to be talking about why ozone and nitric oxide aren't great. I'd probably focus on ozone because it says specifically in here it's talking about ozone, so talk about ozone rather than nitric oxide. So build-up of ozone leads to build-up of photochemical smog. The oxygen can react with hydrocarbons to produce your aldehydes, ketones, and proxyacyl nitrates. The ozone can damage plants, reduce the rate of photosynthesis, or start plant growth. The ozone causes rubber, plastics, and paint to degrade and break down. Ozone also damages skin, and finally ozone is a respiratory irritant. So there you go. Today on Flipping Science we talked about photochemical smog, how it's produced and its effects. That's it for Flipping Science today. See ya.